today's video is going to be about finding rate of change. Now, chances are you have actually probably already learned rate of change. You just may not have learned it by that name. The other name you may have learned it by is slope. Slope is effectively just the same thing as rate of change. Now, the difference, why both terms can be used, is that generally slope is a term that is used earlier on in math careers, and we use it when we are finding just the rate of change for linear lines. And we call it slope, and we refer to it that way for just the linear lines because linear lines are consistent. They have a constant rate of change, right? Once you find the slope between 2 points on a linear line, that's going to be the same slope if you choose 2 other points on that linear line, right? It doesn't matter. When we generally switch to using the term rate of change, quote unquote, is when we start dealing with some higher degree functions whose graphs may not have quite as constant of a rate of change. There may be, different turns and such like that. And so for slope, if you've learned slope before, if you haven't learned slope before, either way, but if you've learned slope before, your formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Real quick review, the idea being you pick any 2 points, and if you pick any 2 coordinate points, you'd have an xy coordinate point and another xy coordinate point, and so we just say designate one of them the first xy coordinate point, and designate one of them the second xy coordinate point, and that's where that slope formula comes from, right? So the idea for rate of change is, well, that slope, while calling it slope is all well and good, if we have a graph like this, well, if you think about that type of shape, it matters which 2 points we are picking. Because if I pick a point here versus a point here, that's going to give me a negative slope, a negative rate of change. But if I pick a point here and a point here, well, now the graph is sloping up. That's going to be positive. So for rate of change, basically what we're saying is we're still finding the same thing we were finding with slope, but we are only going to find that rate of change for a specific part of the graph, or in other words, a specific interval of the graph, which is why this relates to the interval notation video that we've done earlier. And so the other difference I would say is when you're getting to rate of change, like we've already said, that means you're getting to higher level math concepts, higher level math classes where you are dealing with higher degree functions. You may also see a different version of the slope formula because, as you may know, instead of using y, sometimes we will use function notation for f of x. And so instead, sometimes what you will see for a rate of change formula is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. Now recognize that is not any different than what we already had here, right? These two formulas are effectively saying the same thing. It's just instead of using y's, we've swapped that out for f of x's because that's the more, grown-up way of referring to y, however you want to say. That's the way we will refer to y's a lot of times in the higher level math classes. All right? So, for an example, let's say you were given this graph right here. I've gone ahead and marked out some important points. If you are taking notes on this, you may want to pause and draw this out. But the question being asked here is, what is the rate of change over the interval -4 to +1? We've talked about interval notation in an earlier video. This is referring to the x-coordinates. Okay, it is referring to the x-coordinates, so it's saying find where x is -4. That'd be, let's use the wrong color. That'd be this point right here, right? That's where the x value is -4. And then we want to find where the x value is +1. And so the x value is +1 right here. So what we're going to do then is we are going to find the rate of change just between those 2 points. We're going to forget about the rest of this graph. We're not going to worry about the rest of this graph just for these 2 points. Okay? And so that means we want to designate one of these points, our x sub 1, y sub 1, or our x sub 1, f of x sub 1. Then we want to designate one of them the x sub 2, y sub 2, or x sub 2, f of x sub 2. Just like with slope, it does not matter which order you want to go. It doesn't matter which one you pick as your first point versus your second point. I'll just go from left to right. So we will say the point -4, positive 2 is our x sub 1, f of x sub 1. And we will say the point 1, 0 is our x sub 2, f of x sub 2. And so in order to solve out the average rate of change, our rate of change, we are going to take f of x sub 2 minus f of x sub 1 divided by x sub 2 minus x sub 1. Plugging these in then, that means we'd be taking 0 minus 2 and 1 minus a -4. Make sure you don't forget to have the double negative there, because one of the minuses, one of these subtractions, is coming from the formula, and the other is coming from the actual coordinate point. So 0 minus 2 would just be -2, and we know that 1 minus a -4 is the same thing as 1 plus 4. 1 plus 4 would give us 5. And that would be our answer for the average rate of change over the interval -4, 1.